Hello everyone, welcome to this amazing YouTube channel Programming with DP Wala. Hope you all are doing good. So today we are discussing the problems from the Leetcode weekly contest 395. So this contest is relatively on the tougher side we can say. The problem 2, 3 and 4 from this contest was really very amazing as compared to normal Leetcode contest. So let's discuss the third problem from this contest, that is minimum array end. So this problem required a knowledge of bit manipulation concepts. So if you have a knowledge of binary representation and bit manipulation, then you can do this problem. So let's discuss this. So here in this problem we are given two values n and x, and what we need to do here is that we need to construct an array of positive integers nums of size n, where it should be strictly in the increasing order. Here you can say nums of I plus 1 should be greater than nums of I. And at last, what one more condition they have given, which is that the result of all the elements in the array that we have constructed should be equal to x that they have given. And one more thing that needs to be take care here is that the nums of n minus 1 means the last element of that array that you have constructed should be minimum. So n and x is given, need to construct an array, and last element should be less than, or we can say should be minimum, and all the bitwise end of all the elements in the array should be equal to x. Hope you got the question. So let's understand this with the help of an example. So here what we need to do, let's say we are given an n equal to 3 and x is equal to 4. Let's say we are given n equal to 3 and x is equal to 4. So we need to create an array of size 3. Here you can see that. The first element should be this, second element, let's say we have these three elements. Currently there is nothing, but let's assume it. These are my elements. And at last, after performing AND operation of all that elements, it should be equal to x. So the binary representation of this x we require, right? So let's assume the binary representation of this x is this, let's say, right, 1 to 4. So binary representation of 4 is this, correct? Here, if we need to make the all the bitwise end of all the elements be equivalent to x, so what we required, here you can see that if you know the basic uh, AND operation thing, when the element, or we can say a bit is 1, when you do a AND operation of two elements, when the bit is 1, when both are having that bit as set, right? So at this position we must have all the bits set in all these elements that are present. Let's say we are having an element here which is having a 4 bit, right? We are assuming we are doing this for this element only, right? So at this position this bit should be set. Similarly for this, the second bit should be set. Similarly for this element, second bit should be that, because after that only the element becomes equal to x, right? Hope you got the thing. If all the bits are set at that position, then only this bit will be set, correct? Here they have mentioned that the result of bitwise end of operation of all the element is x, we should require it. So the first case that needs to be handled is that you need to take care of that the bit which is set in x should be set in all the elements of the array that you are constructing. This is first case that you need to be consider. The next thing that needs to be take care is that now what we need to do, we need to make we need to put the elements in the array, right? So you will be thinking that as they have mentioned that we need to make this last element smaller, correct? And along with this we need to be take care that all the elements in the array should be in increasing order. Nums of I plus 1 should be greater than nums of I, right? So the thing you can do is that here is that, let's say here, if you are putting some value, let's say, so as one bit is already fixed, as we get it from this x binary representation. So let's assume, take care of this first element. So here the first element is having 4 bits, let's say, and this bit is fixed. And as we know that we need to minimize this, so this will be minimized when we are making all the previous elements should be minimized. Means if you are assuming that, let's mark all the bits at 0, means like this, 0 0 and 0, and make x equal to the last element of array. But this is not a right thing. The reason is that you need to take care of the last condition that they given, that array should be in increasing order. If you mark this element equal to x, then your array should not in increasing order, right? So the first element should be equal to x. This is the case. The first element, we need to make the first element minimize. Let's assume that, because if we make first element minimize, then we will try to make second element minimize, which is slightly greater than the previous one. Similarly, in that format, we'll be ultimately reaching till end, and the end element should be minimized in somewhat. So the first element should be this. Let's consider the second element. Second element here as well, the uh, this bit is set. Now we need to minimize it. Then we need to make it slightly greater than the previous one, that is this is 4, let's say. Minimize it. So what you can do, you can mark this element as 0, mark this as 1, mark this as 0, because the best way is that you can mark this as 1. If you mark sorry, here you can simply mark this as 1. Sorry, by mistake. You can mark this as 1. The reason is that you are setting the first bit, because this is 2 to the power 0, right? This is 2 to the power 1. So if you mark first as 1, then you are just making it smaller, just and greater than the previous one, right? So you are making it this one, correct? So this is 5, which is simply previously greater than 1, right? Similarly, if we are at last element, as previously what we have done, we have marked this as 1. Now what we can do, we can mark this as 1 and mark this as 0 and 0, as this bit is fixed, so it is already 1. So now what this is 6, correct? So what we are doing, we are checking from we are trying to make every element minimized, and whenever we are moving to next element, we are trying to make it slightly greater than the previous one, which which were the we can say the bit which is possible to make mark at 1 or 0, we mark it as 0 or 1 and make it quite minimized, just greater than the previous one. So at every point we need to check for the best possible one. So here you can see that every time what we are doing, we are here you can see that what we have done, we have just make all the remaining bits at 0, right? Here what we have done, we have make only one bit as 1 and remaining or 0. What we have done here, we have uh, let's say this is 2, as we are 2 to the power 1. So 2 bit as set, remaining all are 0. So you are seeing that we are following a sequence 0 1 2, similarly till n minus 1, correct? So here the catch is that to make the last element as minimized, what you need to do, first you need to make a binary representation of x, check whichever bit is set, mark all the bits of that particular number as set as similar to x. Then from this first element start, what you need to do, you need to fill the remaining bits. For filling the remaining bits, perform this operation. For the first element, put all the bits, remaining bits at 0. In second element, only put a first, we can say 2 to the power 0th bit as 1. For the second element, put the 2 to the power means the second bit, that is 2 as set. In this manner, at last you will be getting a minimum n minus 1 value, minimum last value. So this sequence is nothing but we need to check fill the n minus 1 bit, right? So this is the intuition behind this problem. This problem is not very difficult. If you try to dry run over with the help of pen and paper, you will definitely get the approach behind it. Simply we are doing that. We are calculating the binary representation of x and binary representation of n minus 1. Here you can see we started with 0 and we are coming at n minus 1. So n minus 1 bit we will be setting it, and at last what we'll be checking? We'll be checking that if the bit is already 1, means it has been set with respect to x value. So we'll simply ignore it and we'll be mark the remaining bits which is possible. So let's see its code. Hope you will get the approach behind it by seeing the code easily. This is the overall intuition behind it. The problem is not very difficult, just a basic knowledge of bit manipulation is required. So here what I have done, so here you can see that I've created two vectors v and u. V is storing the binary representation of x and u is storing the binary representation of n minus 1. So here I have done n into n is equal to n minus 1. The reason is that you don't need to do it for the all the array elements. You don't need to construct the all the array elements because we need to calculate for the last element only. Just for explaining purpose, I have tried to create for all the elements. But we need to do it for the last element only, and last element remaining bits if we need to set, it is just n minus 1 as I have proved it. So just create a vector for binary representation of n minus 1. So here I have created a binary u vector for that. N minus 1 I have done. Then I have calculated the binary representation of that. After that, what we need to do, as I have mentioned that if the x bit array is already set, means it has been done with respect to x value, because x value we need to make the bitwise end of all the elements equivalent to x. So the all the bits which are set as 1 needs to be same only, so we don't do anything. Otherwise we will be setting the n bit array that we have make the remaining bits, we'll be making it equal to x bit, uh, and we'll be incrementing j, and at last we'll be calculating a number representation of that binary form, and at last we'll be returning that. So very simple thing I have done, just done the binary representation of x, binary representation of n minus 1, try to fill the remaining bits which are not set with the help of this. If it's already set, means it has been done by x, and at last we'll be calculating that entire decimal representation of that binary form. And this is the overall approach behind this problem, and hope you got the intuition behind it, how I proved my solution and how I come up with the most appropriate approach. And always try to think in terms of we can say optimal solution at particular point. We are here as well, we are representing it in a binary form and we're trying to minimize the uh, answer for on that particular bit, right? So try to use pen and paper and dry run over test cases. You will definitely able to solve the problem. Try to write the code by your own and try to dry run over more test cases, and you will definitely get the approach. Thank you for watching this video till this point. Please don't forget to like, share and subscribe to my YouTube channel and stay connected for more such code shape, lead code and code forces contest analysis. Thank you. Happy coding.